A very good day, Madam Farah. My name is Natalie Christopher. My metric number is TB19060. Today, I will be demonstrating the hydraulic lift experiment, which is one of Pascal's law application. What is Pascal's law? The Pascal's law states that when a change in pressure is applied to an enclosed fluid, it is transmitted uniformly to all parts of the fluid and to the walls of its container. Next is the objectives of the experiment. The first objective is to prove the Pascal's law, which states that when a change in pressure is applied to an enclosed fluid, it is transmitted uniformly to all parts of the fluid and to the walls of its container. The second objective is to determine the force needed to apply to the small shrink to lift the 100 grams of water.
The things needed for the experiment are 1 small shrink, 1 big shrink, a tube, a sellotape, a scissor, a container lid, red food coloring, a glass of water, 100 grams of water, and a shoe box. Next is to set up the experiment. Firstly, make 1 big hole and 1 small hole on the shoe box. Secondly, take the big shrink plunger and stick the plunger to the lid of the container by using sellotape. Thirdly, take the big shrink and stick onto the big hole in the shoe box by using sellotape. Then, take the plunger of the big shrink and push it inside the big shrink. Fifthly, stick the big shrink nozzle into one side of the tube and the other tube to the small hole on the box. Next, put a few drops of red food coloring into the glass of water. Then, take the small shrink and pull its plunger to fill in water into it. After that, stick the small shrink nozzle to the other tube. Make sure both shrink nozzles are stick tightly to the tube to make sure no water leak. Lastly, put the 100 grams of water on top of the container lid. All set. Now, let's do the experiment. Press down the plunger of the small shrink.
This is the observation in the experiment. The first picture shows the hydraulic lift before force is applied to the small shrink plunger. The second picture shows the hydraulic lift after force is applied to the small shrink plunger. The 100 grams of water on top of the container lid was lifted. Next is the calculation to determine the force needed to apply to the small shrink to lift the 100 grams of water. According to the Pascal principle, in an enclosed container that contains fluid, the pressure is equal everywhere. Moreover, the force needed to lift an object is less than the weight of the object. As seen on the picture, F1 is the input force of the small shrink. F2 is the weight of the water. A1 is the cross-sectional area of the small shrink. A2 is the cross-sectional area of the big shrink. P1 is the pressure of the small shrink and P2 is the pressure of the big shrink. Now, as seen here, this is the Pascal's law formula where force is equal to pressure times the area. On the previous slide, it is said that in an enclosed container that contains fluid, the pressure is equal everywhere. So, in the experiment, the pressure of the small shrink is equal to the pressure of the big shrink. To find the pressure, we rearrange the Pascal's law formula, and to find the pressure is force divided with the area. Now, to find the force needed to apply to the small shrink, we rearrange the equation and we get like this. F1 equal to the area of the small shrink divided to the area of the big shrink times the weight of the water. This is the value of A1, A2, and F2. The first picture shows the small shrink cross-sectional area A1, which is equal to 1 cm. The second picture shows the big shrink cross-sectional area A2, which is equal to 1.5 cm. And the third picture is the F2, which is the weight of the water, 100 grams. Now, fill in the value of A1, A2, and F2 to the equation. Do the calculation, and the value of force needed to apply to the small shrink to lift the 100 grams of water is 0.44 Newton. In conclusion, the hydraulic lift experiment has proved the Pascal's law of principle, which states that when a change in pressure is applied to an enclosed fluid, it is transmitted uniformly to all parts of the fluid and to the walls of its container. Moreover, according to the Pascal's principle, the force needed to lift an object is less than the weight of the object. It is proved in the experiment by doing calculation where the force needed to lift the 100 grams of water is 44.43 grams or 0.44 Newton, which is lesser than the weight of the water, 100 grams. So, that is all from me. Thanks for watching.